Hi, I'm Ed Moschetti from Control Specialties. We're going to take a few minutes and look at a quick PowerPoint presentation and give you some additional information that may be handy to you on looking at formulas and data as they relate to steam and compressed air systems. Let's bring up a fill tip highlighter here to help us take a look at some of this information. Natural gas is typically the most common fuel used in boilers, and there are typically four measurements that are used to express natural gas flow rates. The ones that you're going to typically see on your gas bill is either going to be a therm, which is 100,000 BTUs, so therefore it would take 10 therms to equal 1 million BTUs, and the decatherm. The quickest way to tell the difference of these two is if you've got a cost per unit of gas that's somewhere in the whole dollar range. For instance, it is $9, then you're looking at decatherms. If you see a cost which is like 90 cents, that would be for a therm. So if you multiply by 10, that would get you the equivalent number. And then these are also measurements which are used more on the boiler side of the equation and flow rates going to the boilers, which is either in terms of cubic feet of natural gas or its equivalent in sort of using scientific notation and shorthand, which is 1 MCF, which is also 1,000 cubic feet of gas. The other measurements here are for other fuels which are used to operate a boiler. So we've got electricity. Notice it takes 293.1 kilowatts to equal 1 million BTUs. And then 7.29 gallons of number 2 oil, which is also, by the way, the same as diesel fuel without the road tax, and then 10.93 gallons of propane. These last two pieces of information here are handy conversions that you may want to keep sort of in the back of your mind if you were looking at the operations of a boiler, so you can look at the amount of steam being put out for boiler horsepower and also the number of horsepower required to make 1,000 pounds of steam. If we look at just some conversion information, for instance, for a boiler which is operating at an efficiency of 80% and of course making steam, if we had a natural gas cost of $7 per MCF or per decatherm or 70 cents per therm, all those numbers are the same expression, then at a boiler efficiency of 80%, your cost of steam would be $8.75 per 1,000 pounds, or if you're doing this on the basis of an hour, 1,000 pounds per hour. To arrive at figures for other gas values, you would just simply take the gas cost per million BTUs and divide that by the boiler efficiency. So as an example, if your gas cost was $9, and again your boiler efficiency is 80%, then your cost for steam would be $11.25 per 1,000 pounds. For compressed air at an operating pressure of 100 psig, the assumption we've used here is that a typical compressor will put out about 4.3 CFM of air per compressor horsepower. So just as an example, if you've got an electrical cost of 6 cents per kilowatt hour, then every 1,000 cubic feet of air that you're producing is going to cost you 17.3 cents. Compressed air, by the way, is a very expensive utility, and it doesn't take a whole lot of air being leaked out of a device or a leak or whatever to start to cost you a significant amount of money. These are some common conversions which again are very handy. The first three really have to do with boiler operations and steam system. Anytime you get involved around a steam system, you always have water flow rates, whether it's feed water going into the boiler or the steam being condensed into condensate. And again, the most common conversion here is 1 gallon per minute is the equivalent flow rate of 500 pounds per hour. Here's the figure that we use typically for a compressor at 100 psig, which is 4.3 CFM of air. This is the conversion for motor horsepower to kilowatts, and then kilowatts to BTUs. Another handy one to hang on to, that a water column of 20 inches high is equal to 1 pound per square inch. And of course 14.7 pounds per square inch absolute is the same as 0 psig, since all pressure gauges automatically just simply eliminate the atmospheric pressure reading. So when you have a gauge sitting on your table, it reads 0, but in fact the pressure at sea level is 14.7. This is the conversion for CFM to pounds per hour of area. And then these last two figures here are for vacuum measurements to convert from percentage of vacuum to mercury and also to torr. And then for cooling, 12,000 BTUs is equal to 1 ton of cooling. All handy pieces of information to allow you to maneuver through your system. There are some steam formulas which are used, and the assumption here is that the value for the heat of steam is 1,000 BTUs. For heating water with steam, Q, which is the amount of steam required in pounds per hour, would be the gallons per minute of water to be heated divided by 2, divided times the temperature rise. And for heating air, again it would be the cubic feet of air divided by 800 times the temperature rise. And for heating oil, with a specific heat of about 0.4, you would divide by 4 the gallons per minute being flowed to being heated, and then multiply that by the temperature rise. If you do these calculations for some other source of energy other than steam, realize that this figure that you're going to get here is going to be expressed in units of 1,000 BTUs. So if you happen to get a calculation here of 100, if you want to convert that to BTUs, you would add 3 zeros, which would make it 100,000. We hope these little conversions have been of help to you, and there's a lot more information on our website to allow you to make these conversions, and if you need further information, you're always welcome to pick up the phone and give us a call. Thank you so much for your time, and we hope you've enjoyed this little presentation.